Listen up, because today we are tackling something that trips up almost everyone. Welcome to the strategy session. Think about a master jazz musician for a second. When they play, it sounds like pure magic, right? Completely improvised, totally free. But here's the secret. They can only break the rules creatively because they have completely mastered the underlying scales and structure. Exam strategy is exactly the same. You cannot improvise a top-tier answer in your Cambridge AS and A-level Computer Science 9618 exam without mastering the fundamental scales. And in our world, those scales are the core database principles. Today, we're demystifying one of the absolute hardest areas of the syllabus, foreign keys and referential integrity. We aren't just going to read textbook definitions here. We are going to build a strategic, foolproof system for you to secure maximum marks.
I want you to look really closely at this quote. This is pulled straight from the examiner's playbook. When the senior examiners sit down, get the red pens out, and review thousands upon thousands of papers, they consistently flag this exact topic as a massive stumbling block. Students just do not get it. They memorize a paragraph from a textbook, vomit it onto the page, and expect full marks. It doesn't work. The examiners are literally telling us what goes wrong. So as your strategist today, my goal is simple. We are going to fix that right now. We're going to build the analytical depth that graders are actively, desperately searching for.
Here is our roadmap for the session. 1. The examiner's perspective. 2. Core principles. 3. The procedural framework. And 4. Critical analysis strategy. Let's get right into it.
Starting with Section 1, the examiner's perspective.
Okay, based on principal examiner reports, students consistently hemorrhage marks by falling into these 3 specific traps. Let me paint a picture for you. Imagine 2 students taking this exact paper. Let's call them Alex and Sam. Now, Alex is a hard worker. He overloads his answers with raw computer science facts, but his answers are incredibly vague. He just dumps information without specific technical details linking back to the database. That's warning number 1. The examiner reads it, sighs, and gives 0 marks for analysis. Then you have Sam. Sam rushes. Sam completely misses the command word requirements and forgets to check boundary conditions and edge cases. And the biggest trap of all, warning number 3, Sam's answers are completely disconnected from the context of the question. You literally cannot just paste a memorized definition of a foreign key. If the question is about a hospital database, your answer must be about doctors, patients, and ward IDs.
And this brings us to the ultimate showdown: superficial breadth versus analytical depth. The Cambridge Assessment Framework doesn't care if you know a tiny bit about 100 different things. They want deep, logical, structured reasoning. It is not enough to just point to a table and say, that's a foreign key. You have to logically explain why referential integrity is maintained in that specific system. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now, because mastering the specific analytical depth is what separates the A-stars from the rest of the pack.
Moving on to Section 2, let's lock down these core principles.
So the conceptual framework here is built on systematic analysis and evidence-based reasoning. Think of a database like a giant, complex bridge. The primary key is the foundation. The foreign key is the steel beam connecting one section to another. Referential integrity, that's the physics guaranteeing the bridge doesn't collapse when you drive a truck over it. When a record is deleted or updated, what happens to the linked data? Does it cascade? Does it get restricted? Your answer needs to draw on these established principles to construct a rock-solid argument for the examiner.
Section 3, the procedural framework.
This is your blueprint. When you open that exam paper and see a nightmare of a database schema, do not panic. You run this 5-step procedural framework. Step 1, deconstruct the question. What is the command word actually asking? Step 2, extract the relevant data from the tables provided. Step 3, select your analytical framework. Step 4, execute your analysis using clear, unambiguous notation. And Step 5, present your findings using the absolute correct terminology. This sequence guarantees you systematically process every single element without dropping easy marks.
Now, pay very close attention to this. This is the method mark strategy. Examiners are begging you to show you're working. Why? Because even if your final conclusion about a database relationship is dead wrong, process marks will literally save your grade. If you show the logical steps, examiners will reward you. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGSC to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGSC and turn on all notifications so you never miss our weekly exam strategy sessions. Remember, the exam is a game of accumulating marks, and method marks are your ultimate safety net.
Finally, Section 4, Critical Analysis Strategy. Treat this matrix like your own personal quality control system. Deconstruct, solve, evaluate. You start by identifying the info and extracting data. Then you break it into logical steps and solve it. But here is the critical part where 90% of students fail, the evaluate column. You have to check your solution for reasonableness. If you set up a foreign key constraint, does it actually maintain referential integrity in the context of the user's business? You need to make justified recommendations. It's like a workshop. You scan the data, you find the flaw in the current system, and you write a highly structured paragraph fixing it.
Now let's pivot slightly to a related hurdle. Senior examiners constantly highlight this exact question. Why do students find evaluating algorithm efficiency so incredibly hard, especially when those algorithms are interacting with these complex relational databases? It is a massive pain point.
The answer is that algorithmic thinking requires juggling multiple variables at once. To successfully evaluate an algorithm's quality, you must explicitly identify its time complexity and space complexity. And remember those edge cases Sam forgot about earlier? You absolutely must consider them. If an algorithm is scanning a database to enforce referential integrity, how does it behave when the database has 0 records? What happens when it hits 10 million records? You have to evaluate the effect on overall performance to get those top-tier marks. If the command word asks you to compare, say, comparing 2 different database schemas or 2 algorithmic approaches, you must follow this rule. You have to identify similarities and differences. Do not just list the differences. And you must use comparative connectives, words like whereas, conversely, or similarly. Every single claim you make needs evidence pulled directly from the scenario, allowing you to draw a highly structured relative conclusion.
So, here is my final challenge to you as we wrap up this explainer. How are you going to apply this exact deconstruct, solve, evaluate framework to your very next past paper? Remember, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.